Okay, we are moving on to lesson 3.2, complex numbers. So we are going to define the imaginary unit I, not find imaginary friends, so that we can rewrite the square of a negative number. We're going to add, subtract, multiply, and divide those complex numbers, and we are also going to find complex solutions of quadratic equations. So we've kind of looked at parts of these before. Now we're going to kind of tie them into things we previously learned. So let's talk about this imaginary unit I, because this is something you haven't learned before. What does it mean? So not all quadratic equations have real number solutions. For example, x squared equals -3 has no real number solutions because the square of any real number is never a negative number. To overcome this problem, mathematicians created an expanded system of numbers using the imaginary unit I. So it is defined as this I is equal to the square root of -1. Note that I squared equals -1. The imaginary unit I can be used to write the square root of any negative number. So we have some examples over here. A numbered example, what we're going to do in order to find the square root of a negative number, because remember, there's no number times itself that would equal a negative. So in order to work this out, we're going to find the square root of -1, and we're going to replace that with I. Then we have a positive square root we can continue on. So let's look at an example. So looking at part A. So we're going to break this up. We're going to take out the -1. We're going to take out the negative square root. So we're just going to take a 1 with it. And then we're going to multiply that by the square root of the positive number in here. So what is the square root of -1? It is simply I. What's the square root of 25? Most of you know it is 5. So you would write your final answer with the I behind the number. So that would be your final answer. All right, let's try another one. So this one we have done actually the positive version of this in a warm-up, depending on how far away you're watching this video is how long ago it was. So we're going to do the same thing. We're going to break it up. We're going to put -1 by itself. Then we're going to do square root of 72. All right, square root of -1 gives us I. Square root of 72, if you remember from our warm-up, we said that 72 could be broken into 36 and 2. So 36 times 2 gives us 72. Well, we know that the square root of 36 is 6, and then we have that. So the way you would write your final answer is you would say 6I square root of 2. So that would be your final answer. Never put I in the back because then it looks like it's in the radical. So it will get marked wrong if your I is not in front of the radical. All right, so see, this number outside is being multiplied to the radical. So we're just going to carry it along as if it's being multiplied. All right, then we're going to break up the -9 into -1 times the square root of +9. All right, now we have -5. Remember, square root of -1 is I, square root of 9 is 3. So now we're just going to multiply our number parts. So -5 times 3 gives us -15I. And that would be your final answer. Okay, so we're just finding the square root. The only difference is if it has a negative, your square root finding is the same. You just simply have an I with it. All right, so I want you guys to pause your screen. I want you to get out your journal, and I want you to try these 4 questions. So please pause your screen and give them a good effort. So I hope that you paused and you actually gave this a try. So the answer to this one, you should have gotten 2I, all right, because the square root of 4 is 2. Now this one, you can split this up in multiple ways, but remember, you need factors that are perfect squares. So we could break this up as -1 times the square root of 4 times the square root of 3. So if you did 6 and 2, that's actually factors, but neither one of them are going to help you find the square root. So then we just said -4 would be 2I square root of 3. So that would be your final answer for that one. right, this one has a negative, so that just means you're going to take a negative along for the ride. Your negative means you're going to have I, and the square root of 36 is 6. So this would be your final answer. All right, and last one. So we need two numbers that when you multiply them, you get 54, where 1 is a perfect square. So we know that 9 times 6 is 54. So you could break this up as 2 times square root of negative 1 times square root of 9 times square root of 6, right? Yes. Okay. So then we have 2 times I times 3 times square root of 6. And then what's 2 times 3? 6. So you have 6I times the square root of 6. And that would be your final answer for that one. So hopefully you got these. If you still need a little practice with those square roots, please go watch that Khan Academy video, or at least practice it in the video. All right, let's move on to example 2. All right, so when we talk about complex numbers, there is a standard form. So the standard form is when you have an addition, you could have a subtraction sign as well, but your constant, your real part, the number is going to come first. Your imaginary part, so whatever with your I, is going to come second. So it should be written in this form. All right, and there's just some information for you. Your complex numbers, they are not real numbers, so our real numbers are separate. If you get an answer where you're multiplying 0 times I, it would fall in this category. All right, so this is just a reference, give you some information. Let's go give these a try. So these actually, most of my classes in the past found these to be quite simple. All right, so if you, I didn't point this out, but if you look at the bottom here, it says that two complex numbers, a plus bi and c plus di, are equal if and only if a is equal to c and b equals d. So what we're going to do in the next problem is we're going to take our a and our c value, set them equal to each other. All right, then we're going to take our b, both our I values, and we're going to set them equal to each other, and we're going to solve. Okay, so looking at this one, what I mean by that is we're going to take our real parts, set them equal to each other. So we have 2x equals 10, and we can solve for x that way. Then we're going to set up, remember our signs go with it, so negative 7i and yi, and solve for y. So we got to solve for x and for y. So the way we're able to do this is we're going to set this up as two equations. 2x equals 10, and we're going to say negative 7i equals yi. Okay? So how do we solve for x? You simply divide by 2. Most of y'all know this. If you don't, you should. And there's your answer. So x is equal to 5. Yes, it was that simple. So now we want y by itself, so we have to get rid of I. Well, they're being multiplied. So how do we undo multiplication? We divide. What are we going to divide by? We're going to divide by I, because that's what we need to do to get rid of to get y by itself. So divide this side by I, divide that side by I. Those cancel out. These cancel out, and now we're left with negative 7 equals y. If that bothers you, you can rewrite that to y equals negative 7. And that's all we had to do. Okay, so we're going to do the same thing for part B. So we're going to set the real parts equal to each other, so 5x and 20. And then we're going to set 4i and 2yi together, and we're going to solve. So we're going to set my two yellow parts up together, so 5x equals 20. And then we're going to set up 4i equals 2yi. So I'm setting yellow equal to yellow, blue equal to blue. And then we're solving. So in order to solve here, I'm going to divide both sides by my coefficient, which is 5, and we get x equals 4. All right, this one I need y by itself. So not only do I need to get rid of the I also need to get rid of the 2. So I could actually divide by both at the same time if that makes you uncomfortable. You could divide by one at a time, so you could do I first, then 2. But I go ahead, I like to get it all done with. So 2 divided by 2 is 1, I divided by I is 1. leaves us with y. So we know these cancel each other out, and we have 4 divided by 2, which equals 2. And so then that's your answer. So these aren't that bad, all right, because all we did was, this was our yellow part we set equal to each other. This was the yellow part in the second one. And then this was the blue part that we set equal to each other. That was the blue part in the second one. Okay, so now I want you to pause your video and I want you to give example 2's self-assessment questions a try. So pause your video in your journal, write these in there, give it a try. This one, we have a negative here and an I here, so we do need to get rid of both. So negative I. So this just means kind of like 3 divided by negative 1, so your answer is just going to be negative 3 and y. And that one's solved. All right, so if you were too nervous to give the next one a try, please pause your video now and give it a try. So hopefully you got this far. You're going to divide both sides by negative 2, and we're just going to leave it like that. X equals negative 9 divided by 2. All right, this side we want y by itself, so we're going to divide both sides by 4i. These i's and the 4's cancel out, leaves us with y. These i's cancel out, leave us with 3/4. All right, so hopefully these weren't too bad. Now the next video we're going to add, subtract, hopefully multiply. I'm trying to make these videos a little shorter in between. So we'll see how much we get done in the next one.